Okay, welcome back to Robbie's Office Hours. Today we're talking about telescoping sums. Why are they called telescoping? Well, my guess is that it has to do with pirates. Because if you've ever watched a good pirate movie, you always have something where there's the land on the horizon, the pirate then pulls out their little telescope, and what do? They extend it, and then they look through it, and then they collapse it down, put it back in their pocket, kind of thing, right? The same kind of idea with telescoping sums. It's something that you're going to expand it, but you're going to get cancellation of all those little telescope segments in the middle that just collapse down. And you'll see this in these coming examples, okay? So let's see how this works. Now again, we're looking at sigma notation, which is a little intimidating, but at the end of the day, it's addition, okay? So what does it mean? Start with k is equal to 0, plug in, then move to k is 1, move to k is 5, and so on, and see what's actually happening. So if I plug in 0, I get 0 plus 1, that's just 1, so I'm going to get 1 squared minus 0 squared. Okay, so that's my k equals 0 term. When k is 1, I'm going to get 1 plus 1, so that's 2 squared minus 1 squared. Okay, next one, k is now 2, so 2 plus 1 is 3. So I'm going to get 3 squared minus 2 squared plus, okay, so that was k is 0, 1, 2, so now k is 3. K is 3, I get 3 plus 1 is 4, so that's 4 squared minus what? K was 0, 1, 2, 3, so that's 3 squared. Okay, so that was k is 0, 1, 2, 3. K is now 4. I'm going to get 5 squared minus 4 squared. 5 squared minus 4 squared. And then plus my last term, I'll just put it down below. K is equal to 5, so that's going to be 5, so 6 squared plus 5 squared. Or 6 squared minus 5 squared, excuse me. Okay? So that's the telescope in fully expanded form, okay? But now what we notice is if we step back for a second, we say, well, look, I have a 1 squared here that's positive, and I'm going to add that to a negative 1 squared here. So that is going to cancel that term. I see 0 squared. I don't see any 0 squareds here. Well, it doesn't matter anyway because it's 0. But anyway, I see a 2 squared here and a minus 2 squared, so that'll cancel that. I see a 3 squared and a minus 3 squared, that'll cancel that. I see a 4 squared minus 4 squared, that'll cancel that. I see a 5 squared and a minus 5 squared, that'll cancel that. Okay, so that's the telescope collapsing down into those different segments, okay? So what do I end up with at the end of the day? I get minus 0 squared, and then I get plus 6 squared, which is just 36. Okay? So that's a very clever way for evaluating summations like this, provided that they actually do collapse, okay, that they do telescope, okay? So let's see what happens with this one. This one's kind of nice because I don't have an upper limit where n is like 5, or n is 10, or n is 70, it doesn't matter. But it's not going to matter at the end of the day because the same process is going to apply. If k is 1, what do I get? I get 2 to the 1 minus 2 squared. If k is 2, I get 2 squared minus 2 cubed. K is 3, I get 2 cubed minus 2 to the 4th. If k is, let's do the second to last term, n minus 1, I'm going to get 2 to the n minus 1 minus 2 to the n. And then the very last term will be k is n, 2 to the n minus 2 to the n plus 1. So that would be 2 to the n minus 2 to the n plus 1. Okay? And then again, we want to step back and say, okay, what terms cancel? I see minus 2 squared plus 2 squared, minus 2 cubed plus 2 cubed, minus 2 to the 4th plus 2 to the 4th. What do I notice is that if I look at two adjacent terms, and I look at the term on the left, I get the minus part is canceling the positive part in the term on the right. So I get minus 2 squared cancels that, minus 2 cubed cancels that, minus 2 to the 4th cancels that. So that means what? There's going to be something here that cancels that, yeah? And there's going to be this guy cancels that. So what am I left with at the end of the day? I'm left with 2 to the 1, which is just 2. Gone, gone, gone. Minus 2 to the n plus 1. Minus 2 to the n plus 1. Okay? So the scary sum, which is all of this, boils down to just these two terms because of the telescoping nature of it, which is pretty cool. Okay? Let's see how this one works. Let's see. These need to be k's. So k plus 1. Okay, so k is equal to 1 to 75, 3 over k minus 3 over k plus 1. Again, start plugging in k. If k is equal to 1, I get 3 over 1. 3 over 1 minus k is 1, 3 over 2, so that's 3 halves. okay, plus k is 2. I'm going to get 3 halves minus 3 thirds. 3 halves minus 3 thirds. You might be asking, like, well, Robbie, 3 thirds is 1, and I'm like, well, that's a fair point. Okay, but I don't really care what the numbers are at this point. I'm just trying to find patterns to see if they'll cancel. So now k is 3, 3 thirds minus 3 fourths. Okay, what's my very last term? That's when k is 75. So 3 over 75 minus 3 over 76. So I get 3 over 75 minus 3 over 76, like that. And I step back and I look at my terms and see what cancels. So let's see. I see a minus 3 over 2 cancels positive 3 over 2. Minus 3 over 3 cancels positive 3 over 3. And again, it's the same cancellation property we had here. The minus term on the left cancels the positive term on the right. So that's going to cancel that. That'll cancel that. And I'm left with 3 over 1, which is just 3, minus 3 over 76. Okay? And again, you can do the arithmetic if you'd like, plug it into a calculator, I don't care. Whatever you need to do to figure out what that number is, that's completely fine. Okay? So that's how telescoping sums work. Now, one thing that I want to point out, which is completely unrelated to telescoping sums, is if you go back to the beginning of the video, these were i's. I made a typo, so k is equal to 1 up to 75, and this is 3 over I minus 3 over I plus 1. But I simply just fixed that, okay? The only way you learn is you have to make mistakes. Okay, so stop thinking about failure as failure. Start looking at it as a learning opportunity, okay? I made a mistake, I put an I here and an I plus 1, big deal, I rectified it, was able to give the example just as is, right? Don't look at failure as failure, look at failure as a learning opportunity. All right, as always, guys, comment down below, give me questions that you want me to solve, anything along those lines, like, subscribe, do all the fun stuff, and we'll keep it going.